Assalamualaikum and a very good day, IBID. My name is Dania Karina Azman, S48546. I am going to present to you about my final year project entitled The Effect of Pyrolysis Temperature and Heating Rate on Gravitic Compound Produced from Waste PET Bottle. My final year project is supervised by Professor T.S. Dr. Cik Muhammad Zaidi bin Ghazali. Plastic pollution has becoming a huge environmental threat to living organisms due to its non-degradable nature. Upcycling is a technique that reuse any discarded objects in such a way to fabricate a product that is valuable and higher quality than the original, such as graphite. Pyrolysis is one of them, which is the degradation of organic materials under the influence of heat and in the absence of oxygen. So this study is attempted to convert waste PET bottle to graphitic compound through pyrolysis. The driving force behind PET recycling is that PET items have a poor rate of natural decomposition, which leads to huge PET waste generated. For years, disposal and incineration in landfill sites has been a typical execution in handling the PET residue that may bring negative impacts to the environment. Hence, pyrolysis have been considered as desirable management options with significant benefit. So the aim of my study is to investigate the effect of pyrolysis temperature and heating rate on the graphitic compound from the conversion of waste PET bottle. And in order to achieve that, my objectives are to study the pyrolysis temperature effect, to study the effect of heating rate, and to analyze the chemical characterization of the graphitic compound produced from the pyrolysis reaction. Most of the studies shown uses pyrolysis as their method with additional steps such as carbonization, gravitization, and the addition of catalysts. In my study, attempt on using direct pyrolysis without any additional steps were done. Methodology, PET bottles was cut finely into flake shape, which then its thermal behavior are analysed by TGA. The sample prepared were pyrolyzed by tube-type furnace. To create an inert environment, nitrogen gas was circulated through the furnace, and each set of experiment has a holding time of 1 hour. The PET flakes was pyrolyzed involving 6 different sets, where lowest temperature chosen is 500 degrees Celsius and highest 1000 degrees Celsius, with 3 different heating rates studied of 5, 10, and 15 degrees Celsius per minute. The samples produced are analysed and characterized by XRD and FTIR to observe the influence of the pyrolysis process on the formation of the gravitic structures. For the result, the physical properties of PET bottle was recorded by observing the weight changes before and after pyrolysis. TGA analysis of the PET bottle justifies the percentage weight loss of the sample produced, as the TGA show that PET bottle undergoes thermal degradation beginning at 429.35 degrees Celsius, and with a total weight loss of 99%, there is a small amount of inert residue remaining of 0.15%. So from the result analysis, 2 pyrolysis temperatures were selected, which are 500 degrees Celsius that acts as a starting point after thermal degradation begins, and 1000 degrees Celsius as the highest temperature due to the plateau of TGA pattern shown that starts at 700 degrees Celsius. Shown on the slide is the XRD analysis that studied the effect of heating rate of each sample from PET-C1 to PET-C6 respectively. From the graphs shown, only PET-C3 and C6 shows favourable result, as both has the most similar pattern with synthetic graphite. Plus, the other graphitic compound formed does not detect any carbon element. From the XRD analysis below, it can be concluded that high heating rate produced a prominent graphitic structure detected by XRD, as PET-C3 and C6 undergone pyrolysis with a heating rate of 15 degrees Celsius per minute. This is due to less time provided for the structural graphitic compound to change. PET-C3 only shows 2 broad peaks, which is at 19.5 degree with low in intensity and large peak width, and an element of carbon dioxide was found, whereas PET-C6 displays 3 broad peaks at 26.2 degree, 43.8 degree, and 44 degree, corresponding to the 002 and 100 crystal planes of the graphite structure respectively, and stipulates that it produces carbon with amorphous structure. Next, both FTIR analysis of PET-C3 and PET-C6 shows presence of functional groups such as alkene, alkane, and alcohol, which are comparable with the functional group presence in the commercial graphite. To conclude, gravitic compound were successfully obtained from the pyrolysis process. Results from the analysis of chemical characterization indicates that the best temperature and heating rate of this research are 1000 degrees Celsius and 15 degrees Celsius per minute respectively. Lower temperature were aimed in this study, which is 500 degrees Celsius and a heating rate of 15 degrees Celsius per minute, but only carbon oxides were detected. Hence, improvements on this research need to be executed. That brings us to the end of the presentation. I would like to thank you for your time and attention. Feel free to ask any questions. I will be happy to open up the discussion. Thank you.